Okay, I'm going to do an example here, and I've got a little like T-shaped beam. All right. I think we could probably all say that this T-shaped beam is made up of two rectangles, like the top rectangle and then this stem rectangle or bottom rectangle. Top rectangle is 8 by 2. Bottom rectangle or the stem rectangle is 6 inches this way, 2 inches that way. So, and then here's the deal. I like moment of inertia about this x-axis, which lies down 2.71 inches from the top. That happens to be the centroidal axis, and I already know that because I figured this out previously by doing centroids. All right? So, the shapes that I have are just, let's say, top and stem for the top rectangle and the stem rectangle. Okay? The centroidal x-axis for the top rectangle lies right there. So my moment of inertia about that centroidal axis would be 1/12. The base would be 8 inches. And the height would be 2 inches. And I got to cube the height. So 1/12 BH cubed. When I calculate that out, I'm going to come up with 5.33, and the units would be inches to the fourth. Okay? My area of the top rectangle is 8 by 2, that's 16. Units would be square inches. Okay? What's the so I've calculated my moment of inertia for this axis as 5.33, but I don't want it about that axis. I want it about this new axis. So what is my D distance from the centroidal axis of the shape, the top rectangle, to the new axis? 0.71 plus 1 inch. 1.71. Okay, because you're 1 inch down to get to here, so it's 1.71. I'm going to take that 1.71, I'm going to square it, and I'm going to multiply it by the area, which is 16 square inches, and I'm going to come up with 46.79. Again, if you're doing units, that'd be inches to the fourth. I'm then going to take this IXC value, I'm going to add it to the AD squared value to get IX total. So 5.33 plus 46.79, and my IX total for this first shape, this top rectangle, is 52.12. Okay? Any questions with that? All right. Now we move on to this other rectangle. I'm calling it the stem rectangle. Its centroidal axis, x-axis, lies right in the middle. So I use the same formula. 1/12. What's my base to this rectangle? Rectangle 6 by 2. What's my base? 2. The base is always the side parallel to the axis. My height is 6. I'm going to cube that. 1/12, 2 times 6 cubed, and I end up with 36. Again, the units would be inches to the fourth. My area of this stem rectangle is 2 by, 2 times 6 would be 12. Okay? What's the D distance? I've calculated moment of inertia about this axis here, but I need to know what this distance is right here. What is that distance? Well, the way I might do it, you might say, well, the centroid here lies how far down into this 6-inch depth?
3.
3. And if I go 3 plus 2, that'd be 5 inches down from the top. If I'm 5 inches down from the top, but I want the distance between here and here, it seemed like I'd take 5 minus the 2.71. How's that sound? That would give me 2.29.
Did you just do 3 minus 0.71? Yeah, that's better.
That's fine. I mean, that's a way to get it, sure. I'm going to square that 2.29. I'm going to multiply it by the area to get the AD squared term. That's 62.93. I'm then going to take my IX. I'm going to add it to AD squared. And I'm going to get an IX total of 98.93. I'm simply then going to add up that IX total column. Here I only got 2 shapes, so there's only 2 values I add up. If I have 8 shapes, there's 8 values that I add up. I add this up in my moment of inertia for this little T-shaped beam about this x-axis is 150, a little over 151 inches to the fourth.